Greetings everyone, my name is Errol Coder and this is Planetary Television. On this episode I'd like to focus on a recent entry from the Planetary Society's blog. The blog is written by Emily Lochtawala, the Planetary Society's Science and Technology Coordinator. On her August 13th blog entry, she writes about the first Trojan asteroid discovered in Neptune's L5 point. If you would like to learn more about the Planetary Society or read more of Emily Lochtawala's entries, please visit planetary.org/blog. Congratulations to Scott Shepard and Chad Trujillo for identifying the first known L5 Trojan asteroid of Neptune. This story is not just interesting because it is the first of its kind discovery, but because of the tricky way that the astronomers went about searching for it, and because of the collateral benefits that their search will have for the New Horizons mission. Here's a newly discovered body, a little blip moving across the background stars. Now I should probably begin by explaining what the heck L5 and Trojan asteroid mean. For a planet in a circular orbit around a star, there exists 5 positions in space called the Lagrangian points, where a third body of much smaller mass could maintain its position with respect to the other 2 bodies. These two of these, L1 and L2, are close to the planet, located closer to the Sun than the planet, and farther from the Sun than the planet, respectively. We use the L1 point, which is between us and the Sun, as a convenient location for solar observing spacecraft like SOHO. We use the L2 point, which is beyond Earth, as an observing space, or a convenient location for spacecraft that look outward, like the Herschel and the Planck. That's where the James Webb Space Telescope will eventually sit. L3 is on the opposite side of the star from the planet. For the pedants out there, yes, I know this discussion applies to more general situations than just planets and stars, but I'm trying to help neophytes imagine the physical situation I'm discussing. Now, the L4 and L5, which are gravitationally balanced points located 60 degrees ahead and 6 degrees behind the planet in the same orbit, respectively. I'll let Wikipedia attempt to explain to you why this is stable. To learn more about it, go ahead and visit Wikipedia and search Lagrange points L5 and L4 and L5. They're the most stable of the Lagrange points, and as a result, there is a lot of stuff sitting at L4 and L5 points, and many of the big bodies in the solar system. Jupiter is accompanied by a boatload, several thousands of these asteroids, which are referred to as Trojan asteroids, and named a bit cutely, I think, for characters in the Iliad. The L4, or leading Trojans, for the Greeks, and the L5, or trailing Trojans, for the Trojan characters. None have yet been found in Saturn or Uranus. Lagrange points, but Neptune has already known to have 6 bodies in its L4 points. Even some of Saturn's moons have other moons sitting in their L4 and L5 points. Telesto and Calypso for Tethys, and Helen and Polydeuces for Dione. If Neptune was already known to have 6 asteroids in its L4 point, why were none known to be an L5 point before now? It's quite simple. Neptune orbits slowly, and over the past several years, while the L4 points have been discovered, the L5 region for Neptune just happen to be near the plane of the galactic center, making it very difficult to observe. Here's what an image of that region of space that contains the newly discovered L5 Trojan looked like a couple years ago. Yikes! It seems ridiculous to go searching for faint bodies in this region of space. Another thing that doesn't help is that Neptune's L5 point is really huge, about 1,500 square degrees on the sky, because bodies in the stable orbits at L5 may liberate up to 30 degrees from the L5 point over time. But Shepard and Trujillo came up with a tricky plan for locating sparse objects against such a dense star field. They took advantage of naturally occurring dust clouds that obscure parts of the star field. The dust clouds are beyond the solar system, so any moving bodies could appear in the foreground, in front of the obscuring dust clouds. So Shepard and Trujillo used images from a wide-field sky survey to locate dust clouds, finding 19 square degrees of them in L5 region. They finally located a single asteroid. Next comes the fun of the statistics of small numbers. If there is one L5 Trojan and 19 square degrees, how many should there be total? They estimate that there should be about 150, give 100 or 200 Neptune L5 Trojans brighter than 24th magnitude, which corresponds to the diameter of 80 kilometers. Other statistics of small numbers based on the 6 known L4 Trojan produced an estimate of 250, give or take 100 L4 Trojans. Within the admittedly quite large uncertainties of these small number statistics, the two numbers match, which is good news. Why do we care about the Neptune Trojans? First of all, their existence and their characteristics of their orbits, especially how inclined the orbits are, provide important conditions on models for how the solar system formed, especially now when most people seem to agree that the outer planets did not form where they are now, that they migrated into their current positions. Such migration would have brought the giant planets into gravitational interaction with smaller bodies lying in the way. The smaller bodies' orbits and profoundly influenced by the motion, the speed of the motion, and the final positions of the planets. That's why, for instance, Pluto's orbits the Sun twice every 3 times Neptune makes the trip. It was shoved into such a resonant orbit by Neptune's migration, much as the Neptune Trojans were forced up and carried into those positions as Neptune moved outward. Also, I thought this was kind of cool. The region of the sky that contains the L5 point of Neptune is the same region of the sky through which New Horizons will travel as it goes beyond Pluto. So searches for bodies in this part of the sky may eventually turn up more distant bodies that New Horizons can visit. No word on whether Shepard and Trujillo found anything beyond Neptune's orbit yet. Why do we care about the Neptune Trojans? First of all, their existence and their characteristics of their orbits, especially how inclined the orbits are, provide important conditions on models for how the solar system formed, especially now when most people seem to agree that the outer planets did not form where they are now, that they migrated into their current positions. Such migration would have brought the giant planets into gravitational interaction with smaller bodies lying in the way. The smaller bodies' orbits and profoundly influenced by the motion, the speed of the motion, and the final positions of the planets. That's why, for instance, Pluto's orbits the Sun twice every 3 times Neptune makes the trip. It was shoved into such a resonant orbit by Neptune's migration